Hello everyone, welcome to MLAS100, Introduction to Machine Learning and Autonomous Systems. I'm very excited to get this course started. It is for a couple of reasons. One, it is one of the largest courses we've ever had. We've got quite a few students enrolled in it this semester, so that's really exciting for a new program. And in addition to that, we've got a lot of new projects that we're talking about doing this academic year. So I'm excited to see everyone jumping into not only this course, but also love to see people in our cybernetics student club. So if you're interested in learning more about that, of course, I am here and can get you in touch with the right people as it relates to our cybernetic projects that we have cooking up this year. Okay, so let me go ahead and jump into our course today. So two big things we're going to do on the agenda, which is one, to cover the syllabus, but then two, to go over the course structure. So let's, without further ado, why don't we go ahead and do that? All right, let me shrink myself over here off to the left, and then let's go ahead and jump into the course itself. So on Canvas, that's how you're going to get to it. So you'll the best way to get to that is go to salinakstate.edu, and then on this particular page you're going to actually go to sign in, and then you go to Canvas. You can get all your information up here right on this page. You've got cases for your student information. You've got Canvas, of course, for your online information that's available, which will have all of your online courses as well as your face-to-face courses are connected here. And then your central hub for Connect. And you've got webmail, and of course, this is our main page. But once you hit Canvas, you get logged in, you go ahead and do your two-factor authentication. You'll be brought to your dashboard, and then you click on MLAS100, and then you'll be brought here. Okay, great. Now, as it relates to the course syllabus and the course structure, let's start off with the front page. So on the front page here, there's a news reader that's going to continue to update. So as you come back, check on this regularly throughout the course. The home here, this home section within the Canvas course will update with latest news from me. So I'll constantly be updating this and letting people know what's going on and what's the latest, what assignments are coming up, what projects are coming up, just kind of keeping us up to date on latest news and events. So the first one is a news release from me to let everyone know here that the syllabus has been released and is updated. You'll want to look through the modules. I will update those weekly. There's not much to look at right now because it's the first week, but I'll be releasing them as we move along. So as we move into the next week, I'll have modules, as we get closer to the end of this week, rather, I'll have module 2 released. And then as we get closer to the end of next week, or rather next week, so 2 weeks from now, I would have module 3 released, so on and so forth. So that's mainly because just to keep people focused on the current content, and that's just something to keep in mind. Okay, one thing I do want to throw out there is that there's a blurb here on a little bit of verbiage on weekly optional sync sessions. This is the link to that. The weekly optional sync session happens on Wednesdays at 4:30 p.m. This is also the same Zoom link for my office hours on Thursday at 12:30 to 1:30. So the good news is you just have to remember the one link and you can get to both. So that's just a bit of info. Additionally, I'd like for you to jump into the Icebreaker Session. Make sure you go into the discussion thread, rather, as one of your first things to do. I'd love to hear from you. Let me know what what program you're in. From a machine learning perspective, if you've got an interest in a project, I'd love to hear about what kind of project interest you have. Because we definitely have a lot of different projects going on, especially when it comes to this area, all things that are artificial intelligence, machine learning, data science. We've got all kinds of really cool projects we're working on. So yeah, I'd love to hear from you on that. And then, of course, if you've got any information or questions, rather, or things you want to run by me, this is my information, my contact information. So mjp001@ksu.edu, as well as my phone number, 785-979-0706. Feel free to email or feel free to text me. Those both work. Okay, that's my contact information. That's the quick high level. Let's go ahead and jump into the syllabus. So the syllabus, from contact information, you've got that. But let's run through some of the course details here real quick. So course number 16074, credit hours 3. This is an online asynchronous course, although there is an optional sync component if you choose to use that. It will be available, and something that could be helpful if you need that extra bit of sync session, and would love to just run things by me or get latest updates on latest happenings regarding machine learning, course topics, anything like that. Those will definitely be things that we talk about in our sync session. Okay. Optional sync session. Course dates 8/22 to 10/14. Again, highlighting that this is an 8-week course. So this is the first 8 weeks. MLAS100 will be the second 8 weeks. So they complement each other. Okay, here's my contact information. Information about around my office hours. I'm also in STC 157. So for the students, there are a few. More than a few, actually, for the in-person machine learning and autonomous systems students that are on campus. I can be found at STC 157. For those that are online, a majority, make sure that you copy my Zoom link. That's something that's useful, again, for my 12:30 to 1:30. I'll also be turning that on for virtual office hours. You'll also notice another name. I have Dr. Pudupeti, Dr. Shri. She is here as a new instructor, a new professor, and she's going to be helping me out. Eventually she'll be teaching this course. I will be teaching this course this semester. But we also have a graduate program in integrated systems design and dynamics. That has a machine learning and autonomous systems component, and I'll be flipping over to help teach on the graduate level, and then Dr. Shri is actually going to be helping out with managing this at the undergrad level. So she's going to be, in addition to tagging along with the course, she'll also be helping out in picking up information. So, okay, let's go jump over to the syllabus and open this up. All right. So here is the syllabus. We've covered course information, instructor contact information. Let's talk about class resources. So there is a digital textbook. I have uploaded that, and I will point that out here in just a second after we get through this. And then we also have some required software. Not anything, again, this is a non-programmatic course, so we've got Adobe Reader, Microsoft PowerPoint, Word, and Teams. Those are the things that we'll be using for this course. There's also a call out to the video, or the movie rather, Free Guy. This is a movie that came out last year. It's a great movie. It's one of my favorite movies. I definitely highly recommend it if you haven't seen it. But we're going to actually analyze the movie. So this is something that we're going to, from a pop culture perspective, this is going to be a really great exercise, because not only does it give us insight into what it is that we do, but it's a great tool to explore insights when it comes to artificial intelligence, and even in a future context, not too far off. Yeah, so that's going to be a nice bonus for us. So optional Zoom session. This is that contact information as well as that meeting ID and passcode. But if you have this link, if you have this link, you'll be in good shape. All right, course description. I'm going to leave this up to you. I do want to make a distinction. Leave this up to you to read. I do want to make a distinction on machine learning and autonomous systems for a second. So machine learning, artificial intelligence, data science, those are concepts we're going to cover in this course. Again, it's not a programmatic version of the course. We're not going to be diving real heavy into programming. We want to kind of ease you into the concepts because there's going to be plenty of time, as you well know, looking through the curriculum. There'll be plenty of time to get into the Python, C, as well as a lot of other different programming languages. You're gonna get into SQL. Some of you may have already covered some of this, but this course and this particular program is real heavy into Python and C. So you'll get this curriculum rather is heavy into that. This course is non-programmatic, so it's introductory concepts. Again, to kind of give you the high level before we get into the details. The other part of it that is very important is the autonomous systems component. So when we talk about artificial intelligence and building AI models, there's a big part of this where you have to take the AI models and learn how to operationalize them within hardware. So our course and our curriculum, rather, is very unique in that respect where we take that to the next level. We don't just teach you how to do the AI part, which is very important, but we also teach you how to do the AI as it relates to operationalizing it and making it an autonomous system. So that's kind of the key here. All right, so course format, we've talked about course format online in an 8-week format and asynchronous. So those are the three big components to take away from that. Course learning outcomes differentiate machine learning from autonomous systems. Topological intersections between machine learning and autonomous systems, of course. And then we'll talk about the major components of computational learning theory as well as cybernetic systems theory early on in this. We'll actually cover that pretty early so that you get a good feel for the differences in computational learning theories. And then, of course, you can't not be in this space and not know what machine learning development life cycles look like. So we'll walk through a lot of that too as part of this course. This course, I'd mentioned it earlier, is broken up into machine learning and autonomous systems. So in the first part of it is we've got 4 weeks, 8 modules that we cover in machine learning, and then we'll do autonomous systems in the final 8 weeks and cover topics in that regard. And you can kind of take a look at what this looks like here, and then here's what the assignment structure looks like. So there's 3 quizzes. They fall in a 2-week cadence. So we'll go through week 1 and 2. So your first quiz will be due in 2 weeks. It'll cover concepts from weeks 1 and 2. Quiz number 2, again, we'll cover quizzes. We'll cover content from weeks 3 and 4. Quiz number 3 for 5 and 6. And then there's a short paper. It's not a really long paper, but it's a little field. I call it a field analysis, or it's not really it's kind of like an informal paper, but it's your analysis based on what we've covered in class, and it only needs to be and there'll be instructions. So when we get there, we'll cover this, but in more detail. But the field analysis, it's a short paper. We're talking less than 5 pages, something more on the order of like 3 pages. But the idea is it's a quick analysis based on what you've learned, using a new lens that you gain around what we call in dimensional gradients of autonomy. So that's, again, we'll cover that when we get closer to that in probably 6 weeks. We'll get closer. When we get to 6 weeks, we'll talk about it. The rest of this is boilerplate. This is all some language in here. I think for me, The only thing I'll say, I'll let everyone read through the rest of this. This is all just information that we have to have on our syllabus from a university perspective. I will make one note on late or missing work. I'm pretty flexible on this, so if you've missed a quiz or you blew past the due date on something, that's all right. Let me know. Life happens. Everyone's working. I totally understand it. I totally get it. One thing I do request is you want to be careful about doing that too many times. Make sure that you are giving yourself enough time to get through the material and truly absorbing it. You don't want to be cramming this all in at the last minute, because I'll kind of quizzes 1, 2, and 3 you can retake to get better grades. It's more reinforcement learning. But when you get into the final, you really kind of have to digest a lot of topics. So I'll understand kind of how well you've been kind of. I will understand how well you've been digesting the concepts in your final paper, and you need to really have a good feel for this. So before you get to cybernetic systems theory and MLAS100, because that's when we get into coding. It's a programmatic course, and you have to. This is a good practice run to get your cadence down. So we developed this course in this way so that you can kind of get a feel for how the work flows. But then when we get to 200, we add in programmatic concepts into what you learn from this. So definitely make sure that you stay with the content and you stick with it weekly, and you'll be fine. You'll be fine if you're sticking with the content weekly. But if you do, again, if something pops up, work happens, life happens, let me know. Keep me posted. And for absolutely, we'll work with you on making sure that we get you through the course. So again, any questions, shoot me an email or text. Okay, that is pretty much the syllabus. Let me bring you back here. I mentioned the MLAS Handbook. This material right here is still in development. All of the machine learning portions of the book are coded out. The good news is that by the time we get to, or rather written, there'll be another version of this that I'm going to publish a little bit later that will have the autonomous systems portion baked out. This is kind of one of those areas that you just can't go Amazon. You can certainly go into Amazon and find a lot of books on machine learning. It's harder to find books on machine learning and autonomous systems. So that's why we've been working on creating our own ebook internally. So this is free. It's available. You don't have to pay anybody. So feel free to download this. It's a great reference reader as we go through the topics, and something that dives into a lot more detail. Okay. Other than that, I think I want to hit assignments and modules, and I think we'll call it a day for our introductory video. So under assignments, I've posted, I will be posting out here in just a second, actually, updates to the course, to the class rather. So as you be looking at your email, but also be looking in this announcements folder, because you never know, you might miss something might pop up, and you may have missed something in an email. I always find it's helpful to go to the home page, because I'll have an announcement on that for everyone. I will also have announcements out to everyone via this link too. So it's just a way to double check. It being an online course, it's good to kind of double check on the communication and make sure everyone's synced up, and that you're synced up with the latest course information. On modules, I'm going to show this out to everyone here. You will not be able to see all of these, because I won't have these all uploaded at the same time. For example, machine learning. So getting started is available. You can click on that. And this is basically a textual version of what I'm doing now. Just in text, kind of run through where to go, what to look at. Course 0, Introduction and Structure, that's this video, so you're in good shape. History of Machine Learning, that's the next module, and then Computational Learning Theory. That's going to cover pretty much the first week. So these three will be the first week, and then applications of machine learning and algorithmic speciation is next week. Introduction to time complexity and big O notation is next week. So that just kind of gives you a feel. On average, just to give you a feel for how the course cadence works, is there's usually 2 modules per week, which comes out to roughly 16 modules, which is usually the normal cadence on a 16-week course. But what we've done is condense that down to 8. So of course we've got 2, and that's why you'll see two modules per week. That's how you want to approach this. This course doesn't have a ton of homework, although it does have a lot of concepts that you want to kind of reinforced concepts within the material, within the content, within the handbook, and within the PowerPoints rather. So we'll be referencing that as we go through, and it's more of a lot of thought experiments that we're going to run through, and changing your perspective on what it means to be in doing machine learning from a cybernetic systems theory perspective. So there's an intersection on what it is that we do from our frame of reference in cybernetics. So machine learning is the techniques and everything that goes into that, but cybernetics is the lens we use when we're developing it. And that is also another unique thing from our program perspective that we teach students, so that they have a frame of reference as it relates to more of an architectural frame of reference as it relates to the hands-on work that you do from a programming perspective. So it'll make more sense as we get to that, but that's just giving you kind of a preview. Okay, next up in Machine Learning Part 2, you'll see here we'll do limitations and statistical biases, machine learning development life cycles, development tools and frameworks, and then of course there's no, would not be a good artificial intelligence course without a discussion on ethics. Next up after that, we switch over to the second part, which is the autonomous systems portion of the course. History of autonomous systems, complexity science. We talk about dimensional gradients of autonomy, architectural derivatives. We talk about also the singularity hypothesis and whether that happens or is going to happen, or who knows what's going to happen with that. But and then we wrap up with introduction to cybernetic systems theory, which is a segue in a good jump point off to MLAS100 for the students that are taking that. Okay. I believe that's all I have for now on your introductory course materials. If you have any questions, again, mjp001@ksu.edu, and then feel free to text me at 785-979-0706. That's all I have, and welcome aboard. I'm very excited everyone's here, and I look forward to meeting every one of you and helping you out with your projects and watching you go through the program. So we'll talk to you soon. Take care.